IGCSE Computer Science Syllabus Statement 1.3.6b, show understanding of the need for interrupts and buffers. So what we're going to do is look at interrupts and buffers, but now this is because we have looked at interrupts and buffers really briefly when we looked at printers, but it's important that we know what actually is going on. So like what an interrupt is, what a buffer is. So that's what we'll do. And then after that, we'll look at how interrupts and buffers are used in printers. So like it's going to be more specific than what we looked at in the printers video. So yeah, let's get started. So an interrupt is a signal sent from a device or software to the processor. And this signal stops the job which the processor is currently carrying out temporarily to service the interrupt. So it's kind of like if someone's, like, you can think of it like this. So if someone's working on something, like if someone's, say, typing something or doing their work, and then somebody comes up and says, "Oh hey, could you please I don't know, could you please carry this box for me?" Or like some kind of task, then what the person can do is interrupt. Well, not interrupt, but yeah. So that person is interrupting that person. So the person who's working can stop what it's doing, what he or she is doing, what they are doing temporarily, and then help the guy carry the box, and then come back to working. So that's pretty much how it works, kinda. So when the interrupt is received, the processor either continues doing what it's doing, so the person working just ignores the person and says, nah, nah. Or it can stop the current task to service the device or program, or in the example, the person which sent the interrupt. Interrupts allow computers to perform multiple tasks, or to have several windows open at the same time. So whenever an interrupt is serviced, the status of the currently running task is saved, and this is done by using an interrupt handler. And once the interrupt has been serviced, the status of the interrupted task is restored, and the processor continues what it is doing, or the task continues, or you get the point. Buffers are a little bit different. So buffers are used in computers as temporary memory. The purpose of buffers is to speed things up, and this is because hardware is very slow compared to a processor. So you can think of it kind of like this. So a processor is sending, let's take a printer for example. Printer is an example of hardware. So like, say the processor of a computer sending data to the printer. Now here's the thing. What the processor needs to do is keep sending the printer data until it's finished printing. Now what this does is the task of sending this data to the printer is the currently running task of the processor. So the processor can't do anything else while this is happening. So this is where buffers come in. So instead of the computer sending data to the printer, it just puts it in this buffer, and the printer can collect the data from the buffer, and the processor can continue whatever it has to do. So it's pretty much like the computer puts this data in the buffer and says, "Oh hey printer, I'm just going to leave this data here in this little box here, this buffer, so you can pick it up from there. I can continue whatever I'm doing." The printer says, "Oh okay." So that's pretty much how it works. Data from a processor or memory unit to be sent to a hardware device is stored in the buffer, and the hardware device can get this data as pretty much what I just said. So let's see how interrupts and buffers work with printers. Now this is a bit weird because the title is kind of, it's a bit weird, but you're going to see why I put it there. The flowchart that I used here is really weird. So any data to send to printer? Nope. Then the processor continues to carry out its tasks. Yes? Then the print data is sent to the buffer from computer memory. The contents of the buffer are emptied to the printer and the printing takes place. All data sent to printer? Nope. The processor can carry out other tasks while the buffer is being emptied, so the processor doesn't have to keep sending the printer data. Yes? Well, when all the data has been printed, an interrupt signal is sent to the processor to request more data to be printed. The current task is stopped temporarily and the interrupt is serviced, so the processor puts more data into the buffer for the printer to collect. So that's pretty much how it works.